use green, and I'm just going to use a bit of a thicker green right now. So, where are the instructions? So the instructions over here says the following. Label and smooth out the curve either manually or using Logger Pro. So right now you probably had a bunch of dots, and then so all that you're going to do is you're going to try to trace out the dots. Now some of you guys had some wonky readings that looked like this. If you did that, don't go and do this, okay? But rather what you want to do is you now know what the trend is. You're just going to follow it with this nice curve like so. Now what you're going to do is you're going to take your ruler, and again I'm going to take the tangent of the bottom over here, and I'm going to go ahead and then I'm just going to draw a straight line across like so. Okay? So it's going to be parallel or tangent to that line, and I'm going to do exactly the same thing for the part that is top right here like so. Okay? Now you might say, oh, should I do it here or wherever? So long as you're just trying to grab part that is relatively flat, that's all I care. And it's tangent, it's touching the line. So now that I've done this, I am now going to take this protractor, and then what I'm going to do is I'm going to draw a line that is 90 degrees to the line that I extended, to the green line. Okay? So I'm going to come over here and I'm going to use my protractor over here, and you guys have the protractor to use. So mine isn't long enough, so I'm just going to go ahead and I'm just going to, if this will let me. Okay? So there's the first part, and this should be 90 degrees. Okay? So now I'm going to do exactly the same thing. Oh, oopsie. So I'm going to do exactly the same thing on this side over here. I'm going to extend this. And as much as possible. Oh, yeah. Okay, there it is. Now that I've drawn this, and so it's 90 degrees to the line that I have just drawn, I'm going to take this and I'm going to use my ruler to measure this line and divide it in half. Okay? So over here, I'm going to measure this line and I'm going to divide it in half. So this is about 7 centimeters. I'm going to pick off a 3.5. Maya, what are you looking at? Okay, so for this one over here on this side, this is about 7.5, so I'm going to have about 3.75, which is over here. So this and this should be the same length, this and this should be the same length. Now what I'm going to do is I'm going to connect these two lines, and what should happen is that where it crosses the line, that is equivalence point. And if you extrapolate back, it should now give you that pH. You guys see that? Okay? Now you're going to do exactly the same thing, and you're going to do it also for your weak acid. So I'm going to use, let's just use hot pink over here. And so what you're going to do is you're going to do exactly the same thing, but this time you're going to find that your line is going to be a lot more sort of skewed. Does that make sense? But your line, your 2 should be here, and then again, after you do this, you're going to draw a line in between, and then it should then cross your weak acid strong base titration curve. So right now I'm going to give you guys about 10 minutes to do this, and then after that we're going to talk a little bit about how you're going to use this data. Okay, time is yours. It does not have the graphs.
Oh, graphs. No, I haven't.
If not, I'm going to give you a sample one to use, okay? Who else does not have a graph?
Yo, go fetch one for me.
Lee, aren't you supposed to like have it upstairs?
I know I did it last night.
Why? Where's mine?
You can share. There isn't many. How much? Wait, how
Lee, you need a handler.
do I draw 90 degrees?
Like, you know, if you're like a pop star, you have a handler. Set your schedule, make sure everything is packed, because you're essentially unable to do it. Because you're not capable of this money. Huh? Well, I don't want to call them personal assistants because they're at the beck and call of the other person at 24 hours. And I don't think Edwin is available 24 hours. That's why we call this adulting.
So we got to measure
90-degree angle.
90 degree over here.
Yeah. From a point.
How'd you charge these down and stuff? You measure this. You just look for 90 degrees. What? You gotta use a protractor. No, not a protractor. These ones.
Which
Just
line?
follow the 90 degrees.
Right here and right there. Here.
And we're gonna do it the same as the other one.
Mm-hmm.
Do we have to use a different color?
Mm-hmm. I don't have a different color, so womp womp.
That line straight off.
I don't even need to draw an angle here. It's just a straight angle. It's a straight line. Wait, no, wrong way. Mm.
Okay, wait. So for here, you gotta come like this shape over here. So how would you draw a straight line? Would you just go like this to this, or you go on like straight line?
Mm-hmm. The same way we did it for the summer. We take the average mean, so here, and it would go. If you see, go whooped, and this one, same line. It go. Did I even use the right one? Either, because they're both the same.
No, I mean for the orange one. You gotta draw on her orange.
It's the same line.
Marking.
Huh?
It's wrong with it, at least for me, right? Because the way I did it, like, this is. I'm measuring not off of the circles, but the way the graph should be, right? So I'm not counting this one, for example, right? Like how she said, if it's all wonky, don't
They're all
count.
different.
Yeah, but like how would you draw a line for the orange one?
It's just like
It's because remember at the end they're supposed to be the same.
You know?
So you could use the same line at the top line for the orange and the red.
half of it.
Yes.
We need lines for both of them, right? Both strands.
They should be the same, no?
No, I meant,
Oh, and then the.
It should be this. That's what I'm saying.
he said. we don't-
They're
we only
not the
use
same,
strong-
but they should be the
No,
same.
that's not what I'm saying.
Indicator,
He said we only do strong acid and strong base.
yeah, and.
I
No, we have to do both of them.
So So like here,
Because she just.
Because she said do the both of them. She's not gonna do everything for us.
point, the pH is at 7, right?
Carissa, come on.
But if I have phenolphthalein changes color up here. Right? So this would be the transition point of the indicator. It's just for the indicator. So if I want the transition point and the equivalence point to be about the same, then I would use an indicator that would change colors at about pH 7, and that would be prothanoline.
What points did you choose? Oh, you chose the line. Okay. I did it. Mine's a bit off. That's fine though.
Yeah, I just choose the middle of the dot.
Yeah, I didn't. Do you have to do the dot?
Yeah.
Okay, then I'll just choose a different dot then.
I mean, it doesn't really matter.
Hello, Basil.
It's 80 degrees.
I would say.
So I draw this line, right? Because did you do the line again?
Yeah. I haven't.
No.
I haven't.
Oh, okay.
Because you gotta-
Yeah, because I'm trying to think like if it's here, right? And then here's 90 degrees. It's here. I don't know if that's right. I don't think
I would say
that would be right. But anyways,
for this one. Can you grab me
There you
a
go.
protractor?
Thank you. We have to choose a. Do you have to choose a point?
I don't know.
I would try to do something a little bit farther. Well, it's just because when you have something so short, just a little bit is going to affect the measurement. Like it might not change anything.
I'm just gonna do the other one with like a dotted line.
So this one is 8.5. So it didn't really change anything.
Ooh, that makes
Yeah, So
sense.
therefore, this is your, so you forgot to smooth this out, right? This goes out.
You have to do the other one too, right?
Right, you're gonna make that.
What did you get for the strong acid? 5, 6, 7. Yeah, it is. Did you draw the slope for the weak acid too?
Is it okay if it's almost 7?
Yeah,
Is it okay if it's almost 7?
yeah.
Your guys' is like lab is kind of
No, it's fine. Like,
You want to show me?
And
feel like-
actually, I don't want to. Just approximate.
You have to find the parallel.
Mhm.
Because, as I said, they're essentially, if they're not the same, then you would have to do something.
And then the part should be the same.
I don't know. I don't know if I did this right. Did I do this right?
It looks fine.
I think so too.
He said, we could do,
As
art and
I heard,
Is it okay to do it all with one
I
color?
heard a good pronunciation of
Do it all with
Zed.
one color?
Because normally it's easy.
Well, I mean, you
Zed.
can,
We're trying to
it's just
call
gonna
it
be hard to
as-
see sometimes.
And I just do that.
Or should play
Much
too much.
easier.
Okay, folks, can I be
Sorry,
attention,
that's
please?
exactly what I thought.
Too much everywhere.
So right now, you guys have taken a look and you have been able to find the equivalence points for both the weak acid, or strong acid, strong base. And then if I did this one, and I'll just use hot ink over here.
Okay.
And I'll just sketch this in, so this one over here, and then I'm gonna go here, so this is my 90 degrees, right here. And since this is about the same, so I'm just gonna come over here. So now notice that I'm going to have to measure a different line here. So let's say this is a half, and over here's a half, and then I'm just gonna draw the line across. So So notice that it hits the weak acid at a different spot. It's slightly higher. So now if you were to extrapolate back over here, then what you'll see is the pH here of the equivalence point is higher than the pH of my strong acid versus strong base. Yes? Okay? And so that's what you're going to be looking for. So if you were to look for how to complete this, in your lab manual over here on page 31, I have incorporated 2 questions. So there's no chart, so on the back of your chart or something like that, you can just complete these 2 things. The first one is identify the pH at equivalence point for your strong acid versus strong base. So all that I'm going to do is I'm going to go into my graph and I'm going to extrapolate back and then figure out what the pH is. I don't really care what your value is because again, you guys were just doing this for the first time and then some of you guys just had some really wonky charts. All that I care about is that you guys are learning to apply and use your pH curves. Then the second one over here, it says, based on your graph, use the volume of NaOH to determine the concentration of the acid. Assume that you use 0.1000100 molar NaOH. So essentially, this is the same calculation like what you guys did in the titration for lab number 10, I believe. Right? Remember the titrations that you guys did? Right? With the burette and everything. Now, in this case, you want to figure out what the volume is, and the volume is that you take this point and you go down, and that's the volume of NaOH that you use. Does that make sense? Okay? And then so if you had a weak acid versus strong base, it may be at a different location. And so what you're going to do is you're going to go in and you're going to do this calculation like you did with the regular titration. And you're like, how do we do it? And so remember when you guys did a regular titration, you basically titrated this until your solution turned a light pink, yes? And then at that point, what did you do? Is you read the volume of the NaOH, didn't you? And then you calculated for the unknown acid. Do you guys remember doing that? So you're doing exactly the same thing, but this time now you're using your pH curve like so, and then you find equivalence point, you extrapolate down. So this is now the volume of NaOH that you use from the graph instead of from the burette. So you're going to do that for HCl, and you're also going to do that for your acetic acid. Okay? And so you're going to just show me the calculations again, so using stoichiometry to complete that. So I don't expect a conclusion. All that I really wanted you guys to get out of the lab was really just appreciating the shape of the curve. How are they the same? How are they different? And what are the changes in pH and why you get these changes? Okay? Are we okay with that? So therefore, if you're looking for the questions, they are on page 31 of your lab manual right over here, and they're found at the bottom. Okay, so if you guys just want to write a reference to that so that you guys can always go back to it after.
Can you use
Once you have done that, what I would like you to do is I would like you to go back to now your notes package, and we're now going to go and talk about hydrolysis on page 107.
Oh, already on it. Great.
Mr. Finnegan. First 20 minutes, right?
Include my graph.
Like give me back your proton.
Okay, here we go.
Do you see me yet? Yes. Do you yet, right?
Okay. Now, when we take a look at hydrolysis, it says the following. Hydrolysis occurs when a salt dissolves in water and its respective anion and cation reacts with water to form either hydronium or hydroxide ions. Okay? This explains why equivalence points in acid and base titrations are not always page 7. Now, I just read this and it was just like, what the heck did I just read? So first of all, I want to highlight some key words here. So over here it says salt. Hydrolysis is when a salt dissolves its water and its respective anion. What charge is an anion? It is negative. So an anion is the negative and the cation is the positive. It reacts with the water. Okay, to form either hydronium ion or hydroxide ion. Okay, salt, positive ion, negative ion, hydronium ion, hydroxide ion. Okay, so let me give you an example. Okay? Is this a hydrolysis? I formed a hydronium. I formed hydronium. Arsa? No? Really?
It's not a salt.
How about this one? Is this a hydrolysis?
I don't know if that's a salt. Maybe.
Raya?
Salt, those are acids. Doesn't salt have to have NA in it?
Huh?
Doesn't salt, actually, I don't know if I'm right. But does salt have to have NA in it? It has to be like NA.
It doesn't have to have an Na. Salt is just another common word for ionic compound. So I could have, instead of NaCl as a salt, I could have LiCl. That's still a salt. How about this one? Okay, so this is your hydronium. How about this one? Is this hydrolysis? Arsa?
No.
No? You sure?
Yes.
I've given 3 examples. At least one of them should be hydrolysis.
But it's Miss Chan, so probably not.
You dare contradict me?
Salt this.
Okay, so you guys picked up on the key word, which is salt. Notice that these 3 that I put in, they are full-fledged acids and bases,
Yes.
right? How do you know? Well, one way of knowing is if you look in the data booklet right over here. Do you see, here's your HCl right over here, and here is your HNO2, and then over here, here is your NH3 right over here. Do you guys see that? So in terms of the salt, it's made from a positive and negative ion that doesn't necessarily have to have that doesn't have an H or an OH in it. So in this case over here, if I gave you an example that looks like this, is this a hydrolysis reaction?
Yes.
Oh, I thought you were gonna say no. Yes? No, why not?
No, there's no, is it because of cation?
So in this case over here, notice over here, you have an NaNO2.
Yes.
So this, first of all, telltale is this is not an H+, nor is this an OH-, yes?
Yes.
So second of all over here is, notice that the NaNO2 broke apart into two separate ions. And then I took one of those ions and I reacted it with water. So notice over here it says the anion or the cation reacts with water.
And
So do I have an ion reacting with water? Yes, I do. How about this one? Is this hydrolysis?
Yeah.
Okay, and this one is. You might say, but wait a second, Ms. Chan. It's on my chart. Yes, it's on your chart, but what is the telltale thing you see? It has a charge. So in this case, when you're taking a look at this, you are looking at the reaction of the ion with water. So I want you to sit back and take a look at the difference between these ones versus this one and this one. What are some things that are different about it, right? Because part of the skill set for you is to be able to distinguish between the two. Notice both of these form hydronium ions, right? Both of these types form hydroxide ions. So therefore, the clue is not whether it formed an hydroxide or a hydronium ion. The clue is what is the identity of that material. So remember when we started with acids and bases, I always say start with what are you working with. So now we have, are we dealing with an acid or are we dealing with a base? Are we dealing with a strong acid? If it's an acid, is it a strong acid or a weak acid? If it's a base, is it a strong base or a weak base? Now it's like, okay, if it's not, if it's a salt, now in terms of the salt, will it now form an acidic or a basic solution? So do you see all of these subcategories that we're dealing with? So with regards to this, does this part now make sense that the anion reacts or the cation reacts with water? Does this part make sense that it has to be a salt? Okay? And are you able to now distinguish between when you have hydrolysis down here and when you don't have hydrolysis? Okay? So that's the first part. Now, I'll skip over the second sentence for a second because let's just continue on. So if you have an anion over here, if you have an anion, when it reacts with water, it will form a base. It will form hydroxide. Now you might want to think about why. What is the mechanism? And the mechanism here is, notice that this is a negative charge, yes? So if it's a negative charge, what does it want to do? It wants to gain a hydrogen ion or gain a proton, right? Positive ion charge. Where is it going to take it from? So if it takes it from the water, what does the water become? It becomes the OH. thus forming a basic solution. So this is why anionic hydrolysis forms a basic solution. Now it says there are only 5 anions that do not hydrolyze, conjugate bases of strong acids, HClO4, Cl minus, H minus, or I minus, Br minus, and NO3 minus. Okay? And so in a way, the clue that you will know is if you go into your data booklet over here, and essentially the ones that I'm looking at are these top ones here. And notice I stop here at H2SO4, okay? And we'll talk about why in a few moments. So in this case, how do you know when it's going to actually react with water or not? And so in this case over here, that is going to be a lingering question, and we'll talk about it after I do cationic. Now cationic over here, I don't really have a mechanism for you. All that I want you guys to do is to memorize that metals from group 1 and group 2 will not hydrolyze except for beryllium. So in a way, this is a bit of your memorization. Now, there are 4 that you should be familiar with: aluminum, iron, chromium, and ammonium. And you're like, do I have to memorize these? No, you don't. Because your data booklet here tells that all to you. So if I go down here, I want you to see, do you see iron right here? There's your iron. If I go further down, right over here, here's my chromium. Do you see that? Okay? Now you might say, well, what the heck is this water? So the whole idea is that when I have iron 3+ in water, it's not floating around like a lonely ion. What water will do is water will surround that ion to basically hydrate it. So that's what is happening over here, and that's why you see that 6 waters around. Do you guys see that? But the waters really don't do anything. It's just surrounding it and just keeping it company. It's kind of like, a really famous actor, and you've got all the people hanging around that famous actor. That's it. And the last one over here, for the metals, is going to be aluminum. And then down at the bottom, do you guys see the NH4? Do you guys see the 4 that's here? 1, 2, 3, and 4. Do you guys see that? So it is all there. Now going back over here, when we take a look, how do we go about sort of figuring out when something is, first of all, when you have a salt and when that salt is going to react with water. So once upon a time in grade 10, you learned about neutralization and you did a titration. So let's say you have HCl plus NaOH giving me NaCl plus H2O. So as you can see, the salt came from an acid and a base, didn't it? So in part, I want you to always link it back to where it came from. So take a look at the Na. It came from NaOH, didn't it? So the positive ion will always come from a base. The Cl came from HCl, didn't it? So your negative ion comes from an acid in general. Now I want you to think about this. You have a strong acid. Well, the Cl technically is the conjugate base, isn't it? Will the conjugate base want to do anything in water? And the answer is, no, it won't. And the reason why it doesn't is because remember that HCl is a strong acid, so it is 100% associated. So therefore, does the conjugate base want to reform the HCl? No. So therefore, it has 0% chance of doing it. So it just hangs out. It's a spectator ion. So now if I take a look at Na, would you agree with me that technically Na is the conjugate base of NaOH, or conjugate acid of NaOH? So if that's the case over here, the NaOH is a strong base, isn't it? Now again, what do you know about the NaOH? What type of base is it? Strong. So if it's 100% this way, then the Na over here is going to be 0%. Right? So now if I just take the Na and I put it into water, is the Na from the NaCl going to do anything? No. Is the Cl from the NaCl going to do anything? No. So therefore, no hydrolysis. Now, let's take a look at another example. What if I gave you something like this? HF plus NaOH. Looks kind of like the one above, right? So now if I go over here, I now have NaF plus H2O. Now again, if you take a look, do you see over here that the NaF came from NaOH and the F came from the HF? Do you guys see that? Would you agree with me that technically Na is the conjugate acid of NaOH? It's a strong base, isn't it? So again, it's 100% going forward. And how many percent going back? 0. So Na has absolutely no desire to reform NaOH. However, if you take a look at HF, is HF a strong acid? So go into your data booklet. Is HF a strong acid? No, it's not. So in this case over here, if I now go in here and say, okay, HF right now will only partially dissociate. So let's say it only dissociates 60%. Why? Because anything that breaks apart, the F is now going to want to reform it back, right? So therefore, the conjugate base here is going to now want to reform that HF. So here's our classification. When you have a strong base, you have a very weak conjugate acid. When something is very strong, its conjugate is very weak. When you have a weak acid in this case, what can you tell me about its conjugate? It is what? It's a stronger conjugate. So this means that F wants to react with water. Does Na want to react with water? Na plus? No, because Na came from a strong base. It's happy separated. F came from a weak acid. It doesn't want to be separated. It wants to go back. And then so what will the F do? It will react with water. Undergoing what? Hydrolysis. And in this case, what type of hydrolysis? Anionic, because anionic is negative ion. Do you guys follow? So you guys probably want to write a little summary. A weak acid will have a stronger conjugate base, or a weak base will have a stronger conjugate acid. Strong base will have a very weak conjugate acid. Strong acid will have a very weak conjugate base. Does that make sense? If it's very strong, it'll be very weak. If it's sort of weak, it'll be much stronger. Does the pattern make sense? Gleb's going, I'm gonna have to re-listen to this one. And again, if you make a compilation and I put it on record,
The only person I would, if I'm going to make the compilation, I'm going to send it to you only. If I'm going to do that.
Not even sick, bro.
Huh?
We have a YouTube channel where you post every chemistry lesson.
All of them, yeah. I'm gonna post it everywhere, and it's gonna be world famous. Yeah. It's gonna be.
Organic chemistry.
It's gonna be more popular than organic chemistry tutor.
So what's the black cat market?
Why are you asking me? I don't know. I don't know cat markets.
Rare pattern.
Why are you asking? I
Only
don't
one
know.
of its kind.
I don't know.
Top flow.
Just because I own cats, I don't know the cat market. What do you? Who do you think I am?
what are you asking, Marissa?
They're asking me about the cat market.
How much is the tax with a specific
Cat. Yeah, you heard. Yeah. C-A-T. Cat.
C-A-T? A meow cat?
Yes.
Why would you want a cat?
He has a cat now, and he wants to sell it. I don't know what he wants with it. Huh?
My family's friend
Yeah.
has a
Obviously, I like cats, but he wants to sell it to me.
like popped into it and gave birth. Oh, he wants to sell it to you.
He wants to sell it to me because he doesn't know what to do with it. I'm like, you think I'm gonna know what to do with it? What
Wait.
I said?
Let's
I
go
might
back.
take it for free, maybe.
So, let's take a look at this one.
But buy it?
So here's our analysis. So here it says predict the acidity of the following. So you have something like NaF. So the logic here is this is a salt. And so the whole idea is just like what we did, and this is why I did this example, is I have my NaF right here. Do you guys see that? So what I'm going to do first of all is I have to go back and say, well, where did the Na come from? And where did the F come from? The Na came from NaOH, didn't it? The F came from the HF, didn't it? So what I would do over here is in my brain, I would say Na came from NaOH, F came from HF. What type of acid or what type of base is NaOH? It's a strong base, isn't it? So if it's a strong base, will Na do anything? No. HF is what type of acid? It's a weak acid, right? So what can you tell me about F, which is its conjugate? It's stronger, isn't it? So will F do anything? Yes. What type of ion is the F? Is it F plus or F minus? It's F minus, that means it's going to undergo anionic hydrolysis. So my solution is going to be what? Basic.
Oh, okay.
So now let's take a look at this next one. So this one again, if I take a look, in my mind's eye, I have to ask what type of acid and base made this salt. So for Na, it's going to be NaOH. And for CO3, let's just stick with this one. You can use the other one if you want. It's HCO3. What do we know about the NaOH? What type of base is it? It's a strong base, so therefore will Na do anything? No, it won't. Okay? For CO3 over here, it's HCO3. Is it a strong acid or a weak acid? It's a weak acid over here. So therefore, will CO3 do anything? Yes, because it's stronger. Now question, is CO3 a positive ion or a negative ion? Yeah.
Negative.
It's negative. So if it's negative, then it's going to undergo anionic hydrolysis, isn't it? So what type of solution does it produce? Basic solution. So over here, this is now going to be basic. one more before I send you guys to try the next few. Okay, NH4Cl. Where did NH4 come from? It came from NH3. Where did Cl come from? HCl. What do you know about HCl? Strong acid. So will Cl do anything? No. NH3, what type of material is it? Strong base? Weak base. We did this first unit. So will NH4 do anything? Yes. What type of ion is NH4? It's a cation. And what did we say about cationic hydrolysis? What type of solution does it make? Acidic. And so over here, this is going to be acidic. Good? Okay, can you guys please try, I'm going to give you like 3 minutes. Can you try numbers 4 to 8?
Where would it come from? Where would NI come from?
Huh?
Where would NI come from? Yeah. Where would it come from? Nickel.
Pretty sure you
Where did that come from? Is it even on here? Not here.
What is it?
Might be a strong base. Strong base.
Wait, if we don't need it.
Cause I don't know where does NI come from?
It's not NO3 too, it's just another.
Is it possible to just go like HI? Replace H with
Tetrasmine.
But it's NI. And that's hydrogen and iodine. This is nickel.
It's not at the bottom. Totally.
Where does NI come from?
What? NI? NI?
Where does NI
It's
come
on
from?
it's on the chart.
Is it?
Yeah.
Where?
Look in the middle, it's in the middle. Yeah, it's near the middle. Like middle bottom. That's bonus sometimes.
There's aluminum. There's Fe. I think they bugging. I don't know. I don't see it. Are we both blind? Where is it
I know
at?
two's like pretty
There's
weak.
AI.
A seems pretty strong, so it must be basic. Yo. NA is strong.
Show it.
Wait, it's neutral. NO3 is also strong.
Wait, where's NI?
What?
Show
I
it.
told you in the middle. Bro, you're distracting me.
Karma.
Yeah, that is broke.
Karma.
That should also buy me some time. CO3.
Do they have it and we don't? You should.
Still on the question.
I think so. What is it? Okay, where does the K come from?
What's
Neutral.
Yeah.
How you doing?
Not well.
We're gonna need that video.
Huh?
We're gonna need
I am so gonna need this video.
We're also gonna be hitting the cat mark.
Yeah, y'all like.
Yep.
Y'all like the.
Am I dumb? Answer's yes.
Four, bro. What?
I'm not blinded.
It's at the top, buddy.
I don't see any K in
We're
here.
good to go. We're good to go.
Where did
Who's done? We're good to go. We're done.
I can just look at the answer sheet.
You need to find an eye.
I can't even find. Open up your thing and point to NI.
I'm already done, bro.
But you don't even know.
Completed
You don't even fucking
Someone
know.
completed the quest.
You didn't
and
even
the
know.
missions again, bro. Must I say I've completed my journey, bro.
Dude,
Yeah,
you just
they go-
looked at the answer key. You just looked at the answer key. Show your work. Show your work.
I did. Have you ever heard of
Okay, show your work for this one.
I did. Have you heard of Plato's Clave before?
Okay. Yeah, I know where NO3 comes from. Where does NI come from?
It doesn't matter, bro. This one is strong. You know what I mean? Like you heard of Plato's Clave?
The what cave? The
Letters
allegory.
of allegory. Must I say?
Those are nothing at all related. What are you getting at?
Came to utmost.
You came? You came. You came in a fruit?
Dude. What? Dude, you should be focused on your work instead of distracting other people.
Bitch. Okay, I could also do what you did.
Sleeping at like 3 o'clock? Yeah. It's 2:57. Leasing myself. There's no I need extra.
Carry right here.
Here, done nothing. Here, done nothing. But you're just really copying. Those are.
That's
Like,
fine.
and you're doing everything wrong. Like, there should be a weak answer.
Yes, okay.
There's a strong answer to a weak answer.
Okay, let's do that
Never
one.
trust her.
Wait, can you genuinely not find NI? Give me. Also good. Bro, why you pull out a data booklet? You know it's at the back of your book. You don't need the data booklet. The data booklet doesn't have some of the stuff.
I don't have it.
Look at the back of your book.
Then how are we gonna do it on a test?
Because these don't come out on the test.
Then why did you
Look at the back of your book.
look at the back of your book?
No,
Why is it different? I did.
you guys are done.
Why do I think it's different?
Yo, your graph is cooked and now you're doing this.
Stop. On my defense, I didn't know that. Why would it not be there?
You guys are done.
Is it there? He said it's not even there.
Dude,
You guys are
that's
not
number
making
5.
it out
That's
of
the only one I don't know.
Number 5.
Come here. Where did you find
You have to
NI?
put number 5.
Where did you find NI?
They're strong on number 4. They're lost in the sauce.
I did the other ones, I just don't know where NI.
It's right there.
My bad. You're right. I'll just do the other one again.
Okay,
It's not the same thing.
what is the number 4 and why did you assign it the label that it was? Yep,
Acidic because an odor from reed comes agent of reed, which is a strong acid.
okay.
And I would come from NiOH.
Okay, so I would probably go and say, yes, it's NiOH, and technically it's a strong base, but I would go back to over here saying that only metals from group 1 and group 2 will not react with water. Right, so if you look at Ni, is it from group 1 or group 2? No, so therefore, it will just react with water on the basis that it is a non-group 1 and group 2. Okay, because the problem here is you've got also solubility issues. Okay? Okay, so therefore this one will because it is not from group 1 or group 2. Okay, second one. Yep.
I thought it's basic.
Okay, why is it basic?
Because like POH is strong base.
Okay?
And like the NO2 is come from the HNO2 and is a weak acid.
Right. So at this point in time, this one will do nothing, this will. Okay? And then we'll finish off with number 6. Last one. Yep.
Because the NA actually strong base and then there's also strong
Okay. So here's what's going to happen. If you guys turn to your worksheets, and you take a look at worksheet number 6,
No.
what you guys would want to try is this first part. These questions will lead to what you guys will be doing tomorrow. The only ones that are going to be a bit tricky is going to be the last 4 here and the one at the bottom of the first column. Second thing that you guys want to prepare for is if you go into your data book, into your lab manual. Have I dismissed you yet? Why is your book away? Is if you guys go into, I believe it is lab number 11. You guys are now going to deal with the hydrolysis. So you're going to actually see what we've been talking about today. However, in this case, there's no pre-lab, just simply because. Now we're only one. Oh, you've got your thing. Where's your book? Is because all that you're going to be doing is you're just going to be putting things into a test tube and adding indicator. So there's really no skill or technique that you guys really need except just to be able to see the color. Okay, so thank you very much. Cheers up.